Section 11.5. We're going to work with find the area of regular polygons. Today we're going to specifically focus on triangles and quadrilaterals that are regular figures. So the first thing we're going to do is we're going to start with triangles. So the area of an equilateral triangle equals the product of 1/4 the square of a side and the square root of 3. So this formula is represented right here, where it says side squared over 4 times root 3, and s is the given side length. So, for example, if you look at the picture that is on the right here, since it's an equilateral triangle, we always know that all of the angles are 60 degrees. If we were to drop an altitude down, so in this picture we have AD, drop an altitude down, you're going to make a 30, 60, 90 triangle, okay? So since this side is represented by S, because all of the sides are the same, we know that the side that is across from the 90 is equal to 2x. So in this case, that's the side length. So the side that's across from the 30 is always going to be half of that. It's just going to be x. So in this case, it's going to be s divided by 2, okay? And we know the height of this is always going to be whatever x is times root 3. So since x is s over 2, we can write this as s over 2 times root 3. You also know that the formula for area of a triangle is area equals 1/2 the length of the base times height. So since the base of this triangle is given to you right here as a variable s, and the height is represented by the s over 2 times root 3, if we were to simplify this right here, we know that s times s is s squared. We know that 2 times 2 is 4 when you're multiplying fractions. So we're going to multiply the 2 and the 2. And then the root 3 is just going to stay multiplied by root 3. So that is equivalent to the formula that we've looked at up here. Now, you don't need to be able to demonstrate that. You really just need to be able to know that if you're given the side of an equilateral triangle, you can use this formula to figure out the area of this equilateral triangle. We just simply proved it to be true by going through that example right here. So again, the main focus is knowing that the equilateral triangle, when you're given a side, to find the area, you square the side, put it over 4, and you multiply that by root 3. We'll do an example of that in a few minutes. So now there's some other vocabulary and other information that we're going to go through. Some of this is new, some of this is stuff that you know. So we can recall that in a regular polygon, all of the interior angles are equal and all the sides are equal. So remember, a regular polygon has all congruent sides, all congruent angles. Now, we're going to talk about something that's a radius of a regular polygon, and that's a segment that is joining the center to any vertex. So if we think about it in terms of maybe a hexagon, we have the center, and then joining it to any vertex, that part right there is called the radius. The next one is a new word. It's called apothem. The apothem of a regular polygon is a segment that is joining the center to the midpoint of any side. Okay, so again, if I were to use my hexagon here, just as a picture, we're going to go ahead and draw that down to the midpoint. So those segments would end up being congruent. Okay, and there's some important information that you want to know about these radii and apothems. So all apothems of a regular polygon are congruent. So any apothem that I would draw to any side to the midpoint, all of those are going to be congruent. Only regular polygons have apophthegms. They do not appear in any other figure. An apophthegm is a radius of a circle that is inscribed in the polygon. So if I were to have a circle like this, and I'm going to inscribe that circle in the polygon, it basically would be the radius of that circle. An apophthegm is the perpendicular bisector of a side. So not only does it connect to the midpoint, it also forms right angles. A radius of a regular polygon is a radius of a circle circumscribed about the polygon. So now circumscribed is when I have the polygon and the circle is drawn on the outside of that. So remember, the radius is drawn from the center to the vertex like that. So that's why it ends up being the radius. A radius of a regular polygon bisects an angle of the polygon. All right, the next theorem that you're going to need to know, this will be the last piece that we need to know for this, and then we're going to go ahead and practice some of these. The area of any regular polygon is equal to 1/2 the product of the apophthegm and the perimeter. So in this case, when you look at this formula, just make sure you know that A is equal to the apophthegm. All right, so we've gone through a lot of information. Let's go ahead and work some of this and see how much of it you can actually use and feel comfortable with here. All right, so next slide. A regular polygon has a perimeter of 40 and an apophthegm of 5. Find the polygon's area. Okay, so let's start with that theorem we just talked about. The area of a regular polygon is represented by the formula 1/2 times the apophthegm times the perimeter. We know the apophthegm is 5. We know the perimeter is 40. We can multiply in any order. So I would take 1/2 of 40, which is 20, and 20 times 5, which is 100. Okay. There's no units on this. If we needed to put units on it, though, remember it'd be square units. All right, an equilateral triangle has a side 10 centimeters long. Find the triangle's area. So if I give you a picture, it's equilateral, all the sides are 10. We're going to try to find the area. Recall that the very formula that we talked about for the area of an equilateral triangle is equal to the side squared over 4 times root 3. So the reason this formula is going to come into play is because I don't have to actually go through and calculate the height, because if I was just going to use the area of a triangle formula, I would need to know the height, and I'd have to figure out that to do 1/2 base times height. Since I don't know that, I only know the side, I can just take 10 squared over 4, multiply it by root 3. So I'd have 100 over 4 times root 3, which is 25 root 3. Again, if I had to have units, I would have that as units squared. All right, the next one. Find the area of an equilateral triangle whose apophthegm is 12. Okay, so let's go through. Let's go ahead and start by drawing the picture of this. So now I'm given the apophthegm. So the apophthegm is drawn from the center to the midpoint. And we know it's 12. And we're trying to find the area of this. So I really need to figure out the length of a side. I know it's an equilateral triangle. So I'm going to go ahead and I'm going to draw another triangle here. I'm going to draw in the radius here. I know, since this is an equilateral triangle, I know all the angles are 60. So by drawing in this radius here, this angle would now be 30. We said before apophthegms are perpendicular. So I'm going to draw this blue triangle kind of large down here so that we can see everything. Okay, so I know the apothem is 12. I know this angle is 30. That automatically makes that angle 60. I need this side that's across from the 60, which remember, that's x root 3. Since our 12 is our x, this is going to be 12 root 3. Now, going back to the original figure, that is 12 root 3. So the apothem also is connected to the midpoint. So I know both of those are going to be 12 root 3. So what's the length of that entire side when I add those together? 24 root 3. So if I go ahead and I use my area formula, area is side squared over 4 times root 3. The length of the side is 24 root 3. It's going to be squared over 4 times root 3. Remember that when you have something like 24 root 3 squared, that means 24 root 3 times 24 root 3. So I actually have to go ahead and I have to calculate this, okay? So we know 24 times 24 is 576. And root 3 times root 3 is 3. So 576 times 3 is equal to 1728 over 4 times root 3. Now, I'm going to simplify 1728 over 4 because it works out to be a whole number, which is 432 root 3. So this is my area. So remember, with any of these problems that we're going through, if you have a question on them, please make sure to reach out to your teacher. But it's also really helpful if you go back and you listen to this video again. And I would recommend that you have both screens open so that you're listening to the video and then you're able to actually calculate and do these problems on your own. At the very minimum on a sheet of paper, but if you have your Classcalc open, you can do it on that as well. So the final page that we're going to go through here has to deal with finding the area of a square given some different information. Okay, so there are 5 different parts to this one. So we're going to end up drawing a square for all of these. So I'm going to kind of jump around here based on the ones that I see that are simple and then go through the ones that I feel are going to be a little bit more challenging. So I'm going to start with B. Okay, the side is 9. It's a square, side is 9. So area for that, pretty simple. 9 times 9, 81 square units. Okay, looking at the rest of these, I might jump to the perimeter one. Okay, if the perimeter is 20. If the perimeter is 20, in order to find the side length, I'm going to divide that by 4. So every side is 5. So the area is going to be 5 times 5, which is 25 square units. Okay, jumping around again. Diagonal is 8. That looks like something I know how to work with. So the diagonal is 8. You know, in a square, you have a 45, 45, 90 triangle. So this is 45, this is 45, that's 90. You also remember in a 45, 45, 90 triangle, hopefully, this is x, this is x, this is x root 2. So in this case, x root 2 is going to equal 8. Okay, I need to figure out what x is, though, to get the side length. So I'm going to divide both sides by root 2. So x is going to equal 8 over root 2. I need to rationalize that to get rid of the root 2. So I have 8 root 2 over 2, which simplifies to 4 root 2. So one side of this square is equal to 4 root 2. So to find the area, I'm going to do 4 root 2 times 4 root 2, which is going to be 16 times 2, which ends up being 32, and again, square units. All right, so at this point, I'm going to work with the new vocabulary words. I have apothem, and I have radius. So let's go with apothem first. Remember, the apothem is drawn from the center to the midpoint. In this case, it's 10 units long. I'm going to draw in the right triangle there. Now it's a square, so I know these angles are going to end up being 45 and 45. And since I know that the 10 is across from one of the 45s, that means the other side over here is also going to be 10. Since I need the entire length of this, and I know the apothem bisects it, they're both going to be 10. So that means one side length there is 20. Not so bad. Actually easier than the one where we just did the diagonal. So if one side is 20, 20 times 20, it's going to be 400 square units. Okay, and the last one I'm going to do is radius is 12. I've got a bunch of work down there, so I'm going to do it over here. So for part D, radius is 12. Okay, again, it's a square. I'm going to draw the picture nice and large. Whenever you're drawing these pictures, the larger you can draw them, typically the easier it is to see all the information. The smaller it is, the harder it is. So this radius is 12. So I'm drawing the triangle. I know that's 90. It's a square. So again, these are 45s. So this is going to be my x. X and my 12 is my x root 2. So I've got to figure out what x is to help me find the side. So if I have 12 is equal to x root 2, I'm going to go ahead and divide by root 2. I'm going to rationalize to get rid of that. So I've got 12 root 2 over 2, which simplifies to 6 root 2. So my x is 6 root 2. That means this part over here, because remember an apothem bisects the side, is also 6 root 2. So the entire length of this side is going to be 12 root 2. So if I'm going to find the area of this square, 12 root 2 times 12 root 2 is going to end up being 144 times 2, which is 288 square units. All right, so at this point we've gone through all the notes. Again, remember, go back and listen to things that were confusing. The next couple slides, slide 8, 9, 10, and 11 are all slides that are your assignment. Please remember to show your work for each part. I know there's not a ton of space on some of these, so if it's easier for you to do your work on a sheet of paper, take a picture of it using this photo tool that's right up there at the top, and then inserting it, that's fine. Enter your answers in the box, and remember to raise your hand on anything that you can't figure out the answer to or anything that you have a question on. But if you're able to enter it and the Classkick verifies that your answer is correct, just go ahead and move on and just make sure your work is on the screen because we can check it. Also remember that when you're writing anything in there with the word, because maybe you have an answer that's like 100 root 3, make sure that you write the word root in place of the square root sign. All right, have a great day, guys. Please reach out if you have any questions. Hope everything is going well for you. If not, you definitely know where to reach us. Contact us if you need us. Otherwise, we'll see you tomorrow.